In the silent depths of the universe, suspended like a distant lantern in the cosmic night, lies a galaxy so distinct, so profoundly elegant, that humanity named it after a timeless earthly icon, the Sombrero Galaxy. Officially known as Messier 104, this celestial marvel rests more than 30 million light-years from Earth, gently glowing amidst the boundless darkness in the constellation Virgo. Imagine drifting closer, sailing through the void, your eyes captured by a luminous disk of starlight, sharply defined and fringed by a mysterious, dark halo. This extraordinary galaxy is no ordinary spiral, its silhouette reminiscent of a broad-brimmed hat turned gracefully towards us, outlined by a striking dust lane. Within this exquisite circle of darkness, an infinite procession of stars dances in harmonious silence, spiraling gracefully toward the brilliant nucleus. At the galaxy's heart lies an enigmatic brilliance, a dazzling core of stars that glows fiercely. This nucleus harbors mysteries that transcend our imagination. Hidden deep within its radiant embrace is one of the most massive and powerful black holes ever observed, quietly reigning at the galaxy's center. This cosmic titan holds in its gravitational grasp stars and gas, orchestrating a celestial symphony of epic proportions. With a mass a billion times that of our Sun, its influence extends across thousands of light-years, shaping the destiny of the entire galaxy. As we peer deeper into this cosmic landscape, we sense the intricate dance between light and shadow. The galaxy's expansive halo glows faintly, home to ancient stars, stellar relics whose soft, golden light tells a story billions of years old. These stars, born in epochs long past, have witnessed the universe transform around them. They have seen countless cosmic dawns, survived untold stellar cataclysms, and now quietly illuminate the endless void, their gentle radiance a whisper from the cosmos's distant past. The Sombrero Galaxy's beauty lies not merely in its grand scale but in the quiet grace of its structure. Its well-defined shape offers us clarity, a perfect natural form sculpted by gravity over billions of years. The galaxy's elegant rings and bands of dust and gas, illuminated by starlight, stretch out gracefully, evoking awe and wonder. They remind us of nature's artistic precision, of cosmic forces patiently working across unimaginable spans of time. Yet, as we stand in awe of its majesty, we recognize our limited perspective. Our view is but a snapshot, a single moment frozen in time. The galaxy's motion is imperceptible to human eyes, yet it spins relentlessly through space, its spiral arms rotating with majestic inevitability. Countless suns blaze and fade, worlds form and perish, life may flourish and vanish, each event concealed by distance, forever hidden from our curious gaze. Astronomers, through powerful telescopes and deep space observations, endeavor to understand galaxies like Sombrero. They study its intricate movements, probe its hidden corners, and trace the gentle glow of ancient starlight. But each discovery only deepens the mystery, hinting at secrets beyond our current understanding. The more we know, the more profound the questions become, reinforcing the humbling notion that our grasp of the universe remains fleeting and delicate. The Sombrero Galaxy serves as a cosmic lighthouse, a celestial beacon guiding our curiosity toward greater cosmic truths. Its delicate structure, mesmerizing appearance, and concealed heart challenge humanity's imagination, urging us to dream, to wonder, and to explore further. This ethereal spiral symbolizes the perpetual beauty of the cosmos, inviting us to look beyond our small planetary home, beyond our solar system, beyond even our Milky Way, toward the infinite realms of deep space. In exploring galaxies like Sombrero, we connect with the universe itself, becoming explorers not just of space, but of time. Every photon of starlight reaching our eyes has traveled millions of years, carrying tales from a distant past, allowing us glimpses of cosmic history. Thus, observing Messier 104 is more than scientific inquiry, it is a profound experience linking humanity to the broader cosmic narrative. For in the quiet majesty of the Sombrero Galaxy, we witness an extraordinary intersection of beauty, mystery, and timeless cosmic harmony, an image that awakens our deepest sense of wonder, humility, and boundless fascination with the universe itself. Beyond its iconic visage and hypnotic beauty, the Sombrero Galaxy conceals subtler secrets, clues to the cosmic choreography that binds the universe. Within its gentle glow, astronomers have observed a tapestry woven from globular clusters, dense collections of hundreds of thousands of ancient stars that drift serenely through its halo. Over 2,000 of these stellar islands orbit the galaxy, each one a separate celestial realm, each a relic carrying a unique cosmic fingerprint from the early universe. When we examine the gentle radiance of these clusters, we see stellar populations nearly as ancient as the cosmos itself, stars whose birth occurred in a young, turbulent universe. By understanding their composition, their age, and their slow, methodical motion around the galaxy, astronomers decode the deeper history of galaxies. Each cluster is like a tiny time capsule, preserving information about cosmic evolution, stories billions of years in the making, waiting patiently to be deciphered by human ingenuity. What makes Sombrero particularly fascinating is its unique balance between spiral and elliptical forms. Unlike typical spiral galaxies, which gleam brightly with abundant star formation in their spiral arms, Sombrero stands somewhat apart. It is serene, less tumultuous, displaying characteristics that place it somewhere between a vibrant spiral and a quiet elliptical galaxy. It sits at the crossroads of galactic evolution, possibly offering a snapshot of transformation. A spiral galaxy gradually transitioning into a mature elliptical form. Its dust lane, so vividly distinct, creates an immense cosmic boundary. Dust, often overlooked, is profoundly important. It is the seedbed from which new stars, new worlds, even life itself may eventually arise. The dark bands encircling Sombrero are reservoirs of cosmic potential, composed of organic molecules, ice crystals, and microscopic grains, particles forged in stellar furnaces, dispersed by supernova explosions, drifting gently through interstellar space until captured by gravity's subtle embrace. Even from our distant vantage point, astronomers discern the faint infrared glow emanating from this dust, revealing complex molecular chemistry quietly unfolding across immense distances. It is a silent, slow-motion alchemy, chemistry on a cosmic scale, that reminds us of our own origins, hinting at the universal processes that unite galaxies and life across the cosmos. Peering closer into the heart of Messier 104, astronomers detect powerful emissions of X-rays and radio waves, generated by intense interactions around its immense black hole. This invisible giant is not merely a passive observer. It profoundly shapes its surroundings. Gas spiraling inward heats up, emitting energy that streams across space, announcing the presence of a hidden giant, a gravitational leviathan at the galaxy's core. Yet this forceful center, paradoxically, brings stability, anchoring the galaxy's rotation and guiding its evolution through cosmic epochs. Sombrero's placement in the sky further enriches our understanding. Situated along the edge of the Virgo galaxy cluster, the largest nearby cosmic metropolis, it provides context to the greater galactic neighborhood. Gravity's invisible threads connect Sombrero to this vast assembly of galaxies, influencing its slow, deliberate motion through space. The subtle gravitational pull of distant galaxies, felt across millions of light-years, gently tugs and guides Sombrero, choreographing a delicate cosmic ballet whose full scale we can barely comprehend. Thus, exploring Messier 104 is not merely an exercise in cosmic sightseeing, it is an exploration of our own place in the universe. It invites reflection on the universal principles shaping galaxies and stars, and inquiry into how vast and distant structures influence one another across the emptiness of space. In its quiet complexity and refined beauty, the Sombrero Galaxy serves as a bridge between the tangible and the unknown, reminding us of the fundamental unity underlying all things. From microscopic particles drifting through space to colossal structures of unimaginable size and power. In every photon captured from its distant light, we hear an echo of cosmic history connecting us intimately to galaxies, stars, dust clouds, and hidden giants that lie across an unimaginable gulf of space and time. The Sombrero Galaxy thus stands as more than just another celestial object. It becomes an emissary of the universe itself, quietly beckoning us deeper into the endless ocean of stars. In the profound silence that envelopes galaxies like Sombrero, we discover layers of cosmic complexity, each subtly speaking to the delicate interplay of creation and destruction that defines our universe. For within every luminous band and shadowed lane of dust, we find echoes of stellar birth and the lingering whispers of stellar death. A perpetual cycle that has sculpted Messier 104's unique character over billions of years. The galaxy's intriguing structural duality, its hybrid nature, partly spiral and partly elliptical, presents astronomers with captivating questions about cosmic evolution. Could Sombrero be the result of ancient galactic collisions, subtle mergers between smaller galaxies, gently uniting under gravity's irresistible pull? Such events, spread over immense stretches of cosmic time, could explain its enigmatic form, suggesting that what we witness today is merely a peaceful, elegant epilogue to once violent cosmic encounters. We marvel at how this celestial giant preserves clarity and symmetry despite the chaotic processes that birthed it. Through detailed observations, astronomers find subtle hints supporting such a merger scenario: streams of faint starlight, vestiges of disrupted galaxies gently absorbed into Sombrero's tranquil embrace. These faint tidal trails, barely visible and stretching outwards like distant echoes, bear silent testimony to dramatic histories long erased by cosmic time yet subtly imprinted into its very structure. Beyond its luminous heart and magnificent disk, we discover invisible realms of cosmic magnetism, vast magnetic fields woven intricately through the fabric of the galaxy itself. These fields thread silently between stars and dust clouds, influencing the movement of gas, guiding it gently towards stellar nurseries or away from energetic outflows emanating from the galactic core. Invisible yet immensely influential, they play a crucial role in shaping Messier 104's evolution, providing invisible hands that sculpt and organize matter across unimaginable distances. With each careful measurement, astronomers perceive traces of this magnetic architecture through polarized starlight, subtle patterns hidden in photons journeying across tens of millions of years to reach our instruments. Such observations deepen our understanding of galactic ecosystems, revealing a galaxy as a delicate, living organism dynamically balanced by the silent but ever-present interplay between gravity, radiation, magnetism, and cosmic turbulence. The Sombrero Galaxy also offers clues about the elusive nature of dark matter, the invisible scaffolding upon which galaxies and entire cosmic structures rest. While its presence is inferred rather than directly observed, astronomers see evidence of this enigmatic substance within Messier 104's outer halo, where stars move in graceful arcs at velocities suggesting hidden mass, an unseen companion vastly outweighing the visible stars and gas. Sombrero thus serves as another window into this profound cosmic mystery, challenging our understanding and prompting us to rethink fundamental assumptions about the very nature of reality itself. Yet, the galaxy's allure goes beyond purely scientific intrigue. It captivates the human imagination, resonating deeply within our collective consciousness, symbolic, majestic, infinitely distant yet intimately familiar. Messier 104 draws us nearer to a fundamental realization that in exploring the cosmos we also explore ourselves. The galaxies we admire from afar mirror the complexity within our own being, each discovery affirming our intrinsic connection to a vast and mysterious universe. In each thoughtful gaze towards Sombrero, in every painstaking analysis of its delicate glow, we become participants in an ancient cosmic dialogue. We join countless generations of curious minds who have gazed upward with wonder, inspired to question, to dream, to envision futures where humanity traverses the boundless cosmic seas. Messier 104, serene yet teeming with hidden drama, thus becomes more than mere astronomical spectacle. It embodies the essence of human exploration, our relentless, beautiful pursuit of understanding our place in this vast, enchanting cosmos. As we move closer into the subtle depths of Sombrero's luminous disk, our vision becomes finely attuned to the intricate interplay of cosmic rhythms. The galaxy, in its quiet radiance, offers astronomers a celestial laboratory, a place to test theories about gravity, cosmic evolution, and the formation of galaxies themselves. Each precise observation contributes another brushstroke to our portrait of the universe, slowly revealing the hidden intricacies behind Messier 104's apparent tranquility. Consider for a moment the steady procession of stars within Sombrero's vast halo, silent guardians orbiting on meticulously ordered trajectories, their motions choreographed by forces beyond visible matter. These stellar sentinels, meticulously tracked through advanced telescopes, demonstrate a harmony rarely seen at such scale. Their smooth orbits speak eloquently about the unseen gravitational architecture sculpting their paths, providing evidence that the fabric of the galaxy is interwoven with invisible matter whose presence we can only infer through its gravitational whispers. Equally fascinating is the galaxy's relative quiescence in terms of star formation. While many spiral galaxies blaze vibrantly with the birth of new stars, Sombrero maintains a quiet dignity, suggesting that its prime epoch of stellar birth may lie far behind. The reason for this cosmic calm intrigues astronomers deeply. Could it be that its vast reservoir of gas, essential fuel for star formation, has already been mostly consumed or dispersed, or perhaps heated by internal processes, making conditions less conducive to stellar creation? These subtle dynamics prompt astronomers to look deeper, carefully examining the faint spectra emanating from its core and dusty rings for answers. This lull in star formation, far from making the galaxy mundane, enriches our understanding of cosmic life cycles. Sombrero gently reminds us of cosmic limits, of the finite nature inherent even in galaxies. It teaches us that celestial bodies too have lifetimes. They age, transform, evolve, and thus, their stories hold lessons about cosmic mortality and renewal. It is in these quiet galaxies, rather than their spectacularly luminous cousins, that astronomers often find the clearest windows into how galaxies mature and age gracefully. Sombrero also plays host to transient phenomena, short-lived events such as stellar explosions known as supernovae. Although rare within its tranquil precincts, each supernova discovered provides a brief yet immensely valuable flash of insight, illuminating regions of the galaxy previously hidden in shadow. The sudden flare of these dying stars, millions of times brighter than their neighbors, enables astronomers to measure cosmic distances with extraordinary accuracy, refining our understanding of the expansion and scale of the universe itself. Another subtle revelation lies in the careful study of Sombrero's spectral fingerprint, light dissected into myriad wavelengths by astronomers. Within these carefully separated lines, we uncover stories of elemental abundance, tracing how the heavy elements crucial to planets, life, and humanity were forged within stellar furnaces and dispersed throughout the galaxy. By carefully analyzing these spectral signatures, we glimpse a cosmic recipe for complexity, one that unites our earthbound lives with distant cosmic realms, reaffirming that the ingredients of our existence are shared throughout the universe. Additionally, modern telescopes equipped with adaptive optics and advanced imaging technologies allow astronomers to pierce through Sombrero's dense dust lanes with remarkable clarity, revealing previously unseen clusters of young, luminous stars hidden deep within its dusty embrace. These findings, subtle yet significant, suggest that even in a galaxy marked by apparent tranquility, pockets of activity still persist. Such hidden enclaves offer tantalizing glimpses into the ongoing cosmic processes that defy simple categorization, illustrating that the universe continually challenges our expectations. Finally, Messier 104's position and its clear visibility in amateur telescopes make it a cosmic ambassador, bridging the gap between professional astronomy and public curiosity. Countless individuals around the world, gazing through modest telescopes in darkened backyards, have felt a sense of personal connection to this galaxy. In this way, Sombrero extends its influence beyond scientific research, embedding itself deeply within our shared human experience. Its distant glow inspires wonder, imagination, and curiosity, quietly urging humanity to expand its vision beyond the confines of everyday life toward an ever-broadening cosmic horizon. In the delicate tapestry of galaxies adorning the cosmic expanse, Sombrero's unique architecture provides astronomers with a precious vantage point, one that challenges our theories and sparks fresh inquiry into the vast and intricate mechanisms governing galactic formation and evolution. Beyond its tranquil countenance, Messier 104 quietly invites us to contemplate the delicate balance of cosmic conditions that sustain such structures across billions of years. Though it appears timeless and serene from our distant viewpoint, the Sombrero Galaxy participates actively in subtle gravitational dialogues with neighboring galaxies. Galactic interactions, though gentle and almost imperceptible across vast expanses, influence the long-term stability and dynamics of Messier 104. Astronomers study these subtle gravitational pulls, mapping the intricate network of cosmic filaments, invisible pathways along which galaxies travel, shaping clusters and superclusters through an unseen gravitational choreography. Sombrero's steady glow also provides clues about the interplay between galaxies and their larger environment, the intergalactic medium. Its halo, extending far beyond its luminous disk, interacts constantly with sparse gas and matter scattered between galaxies, absorbing and sometimes ejecting material in an endless, delicate exchange. Observations indicate that even a galaxy seemingly isolated within the cosmic void engages continuously with the faint, diffuse matter permeating intergalactic space, an ever-present cosmic tide gently reshaping its outer boundaries. Deep within Sombrero's inner regions, astronomers detect subtle signatures of past stellar activity etched into its stellar population. Chemical analysis of its oldest stars reveals evidence of elements created in ancient stellar explosions echoing across the ages. This forensic astronomy reconstructs histories lost to visible observation, piecing together narratives of star formation and death occurring long before humanity's gaze reached the heavens. Moreover, Sombrero provides essential context for understanding cosmic feedback, a phenomenon wherein massive central black holes regulate star formation across entire galaxies. Energy emitted from Sombrero's supermassive core, whether in the form of powerful radiation or subtle outflows of high-energy particles, may serve as a stabilizing force, gently warming surrounding gas and preventing it from cooling into new stellar nurseries. Thus, this distant galaxy illustrates how invisible forces at galactic cores maintain cosmic equilibrium over vast periods of time. Astronomers also turn to Messier 104 for subtle gravitational lensing effects, where the galaxy's immense mass subtly warps the path of distant light passing through its gravitational field. Such lensing reveals otherwise invisible background galaxies, magnifying their faint light and providing glimpses into the very distant universe. In doing so, Sombrero becomes not just an object of study, but also a cosmic lens, transforming itself into a powerful observational tool. Even its orientation relative to Earth provides unique observational advantages. Seen nearly edge-on, Sombrero allows astronomers to study the intricate layering of stars and dust, offering an unmatched clarity into the galaxy's internal structure. Detailed observations at different wavelengths from infrared to ultraviolet unveil hidden features, unveiling a rich landscape of star populations segregated by age, composition, and evolutionary history. Furthermore, Messier 104 becomes a testing ground for innovative astronomical methods, including new generation telescopes, space-based observatories, and computational simulations. Each technological advancement, from adaptive optics to gravitational wave detectors, brings astronomers closer to unraveling Sombrero's deepest secrets. The galaxy thus continuously invites human ingenuity, urging innovation in the tools and techniques that enable us to glimpse deeper into the cosmic story. In exploring this distant galactic island, we also refine our understanding of galactic scale. Sombrero's immense size, over 50,000 light-years across, provides an intuitive sense of cosmic magnitude, translating abstract astronomical scales into something more comprehensible yet still profoundly humbling. It reminds us gently yet persistently of our relative insignificance amid the vast ocean of stars, dust, and darkness that comprises our universe. Thus, Messier 104 quietly endures as a beacon of cosmic contemplation, not simply due to its visual beauty, but through its profound ability to deepen our collective wisdom about the cosmos. Through careful observation, patient study, and thoughtful interpretation, Sombrero draws us into a profound encounter with the infinite, one that continually reshapes our perception of reality and gently beckons humanity ever outward, toward new frontiers of cosmic knowledge. Drifting even deeper into our cosmic contemplation, Sombrero's quiet splendor subtly reveals lessons about cosmic equilibrium, how galaxies preserve their stability amidst relentless universal forces. In Messier 104, astronomers observe a remarkable harmony between opposing dynamics, gravity pushing matter inward to the galaxy's core, and angular momentum gently pulling outward, balancing the entire galactic system like a dancer gracefully holding position. In the galaxy's elegantly pronounced bulge, radiating softly yet powerfully at its core, lies evidence of complex stellar migrations, stars once born far from the center having drifted inward over billions of years. This subtle, inward flow of stars, guided by gravitational tides, suggests a dynamic interplay of stellar populations constantly evolving in delicate response to internal gravitational influences. By decoding these stellar motions, astronomers piece together subtle threads of cosmic history, tracing the galaxy's slow and graceful internal rearrangement. Messier 104's halo also whispers of gravitational ripples, subtle perturbations caused by long-past interactions, distant gravitational echoes resonating through the galaxy's outer edges. These gentle waves in the halo's structure, revealed through precise measurements, suggest hidden interactions that occurred long ago, now only faintly remembered by the galaxy's outer stars. These delicate gravitational imprints speak to a galaxy's remarkable memory, quietly retaining the echoes of encounters long after their visible evidence has faded. Moreover, astronomers studying Sombrero's dynamics examine meticulously its rotational curve, the velocity of stars and gas orbiting at various distances from its center. In its serene rotation, they uncover an unexpected subtlety. Unlike many galaxies whose outer stars orbit at steady speeds, Sombrero's disk reveals intricate variations, hinting at differences in mass distribution and unseen gravitational forces at play within. Such detailed examinations refine astronomers' understanding of how galaxies like Sombrero delicately balance mass, motion, and gravity across vast distances. Additionally, the quiet presence of planetary nebulae, stellar remnants glowing faintly around aging stars, dot Sombrero's halo, illuminating the galaxy's evolutionary timeline. These ghostly celestial clouds provide astronomers with cosmic yardsticks, helping measure the galaxy's expansive dimensions and trace the history of star formation over billions of years. Each nebula, a final breath of a dying star, gently marks the passage of stellar generations, silently narrating stories of life cycles completed far from our terrestrial view. Sombrero's distinct form has also inspired innovative computational modeling, with astronomers simulating galaxy formation processes to replicate its uniquely balanced structure. Through supercomputer-driven simulations, scientists attempt to recreate Sombrero's graceful symmetry, exploring countless scenarios of mergers, gravitational interactions, and gas dynamics. These digital experiments reveal possible evolutionary pathways that galaxies may follow, illuminating the subtle cosmic conditions necessary to sculpt a galaxy of such perfect equilibrium. In exploring Messier 104, astronomers also quietly test the principles of general relativity. The immense gravity of the galaxy's supermassive black hole subtly bends spacetime around it, an effect astronomers strive to measure through observations of nearby stars and gas streams. Each precise measurement deepens our understanding of gravity itself, testing Einstein's profound theories against a natural laboratory set millions of light-years away, yet intimately connected to our intellectual quest for universal truths. Furthermore, through advanced spectroscopy, scientists detect intricate molecular signatures in Sombrero's dust lanes, complex organic molecules drifting silently through its vast expanses. These molecules, precursors to life as we understand it, suggest that the fundamental chemistry of life permeates galaxies throughout the universe. Messier 104 thus subtly underscores the cosmic ubiquity of life's potential, bridging distant galaxies and our own planetary home. Even as telescopes evolve and humanity's vision extends deeper into space, Sombrero remains a quietly powerful guide, challenging and inspiring new generations of astronomers, cosmologists, and dreamers. Its enduring beauty and delicate complexity continuously refine our methods and expand our comprehension, gently teaching humanity humility, curiosity, and persistence in the face of an endlessly expanding cosmic puzzle. As we continue drifting silently through the cosmic twilight toward Sombrero, we begin to recognize it as more than a celestial spectacle. It is an intricate timepiece, subtly marking the passage of cosmic epochs. Every ray of light traveling from its ancient stars carries encoded within it a unique message, chronicling events that occurred when our own planet had not yet seen the dawn of life. Deep within its luminous core lies a subtle interplay of stellar winds, streams of charged particles ejected by giant stars, whispering silently through the galaxy's inner reaches. These winds sculpt the surrounding interstellar medium, subtly altering gas densities and temperature gradients, gently shaping the conditions necessary for star formation or suppression. Observing these stellar breezes helps astronomers better understand how galaxies delicately regulate their internal ecosystems over vast spans of time. Within Sombrero's extensive halo, astronomers carefully track small satellite galaxies, diminutive companions quietly orbiting their majestic host. These miniature galactic neighbors orbit in silent tribute, their delicate gravitational interplay offering valuable clues to galaxy formation. By observing their gentle orbits, astronomers piece together evidence about dark matter distribution, galactic mergers, and subtle gravitational interactions that shaped Messier 104's quiet grandeur. Further, through precise radio astronomy, we discern faint jets of energetic particles emanating from its supermassive black hole, extending gently outward into space. While not as prominent as those in other galaxies, These subtle emissions quietly signify ongoing processes at Sombrero's heart, hinting at dynamic and energetic activities hidden within its serene external facade. These faint, elusive signals allow astronomers a deeper glimpse into the quiet mechanisms that govern supermassive black hole behavior across cosmic time. Remarkably, Sombrero also serves as an observational anchor. Its well-documented distance, luminosity, and precise structural details offer astronomers a valuable reference point. By comparing Messier 104's properties to those of galaxies both near and far, scientists calibrate their cosmic distance measurements, ensuring greater accuracy when mapping the vastness of the universe. Quietly, Sombrero thus becomes a benchmark supporting humanity's quest to chart ever deeper into cosmic history. Its gentle radiance further aids astronomers searching for exoplanets in distant galaxies, a subtle yet groundbreaking frontier in astronomy. Although incredibly challenging, methods developed and refined through observations of galaxies like Sombrero gradually expand our ability to detect faint planetary signals across intergalactic distances. Messier 104 quietly contributes to humanity's growing hope of someday uncovering worlds beyond our Milky Way, possibly harboring forms of life that share our cosmic heritage. Advanced astronomical instruments also increasingly reveal the delicate presence of dwarf stars within Sombrero, tiny, dim stellar bodies quietly enduring within the galaxy's expansive boundaries. These faint stars, previously undetectable, significantly alter estimates of the galaxy's total stellar population, influencing calculations of its mass, age, and evolutionary trajectory. Thus, even Sombrero's quietest inhabitants profoundly reshape our understanding of its true cosmic nature. Similarly, subtle fluctuations in Sombrero's brightness over long periods provide insight into stellar variability. Careful analysis of these gentle oscillations yields clues about stellar interiors, life cycles, and the processes driving stellar evolution. Astronomers, through meticulous monitoring, decode these minute signals, adding layers of depth to our comprehension of stars and their cosmic destinies. In addition, Sombrero's relative isolation within its neighborhood, a galaxy that stands somewhat apart from crowded galaxy clusters, offers researchers the chance to study galaxies evolving independently, free from strong external influences. It quietly becomes a rare natural experiment showcasing how galaxies behave when left predominantly to internal processes, further illuminating the diversity of galactic evolution pathways throughout the universe. Thus, in countless subtle ways, Sombrero continues to quietly enhance humanity's perspective on the cosmos, becoming an essential participant in our exploration of the universe. Each observation, each measurement, each nuanced revelation brought forth by Messier 104 expands our cosmic awareness, bridging distant galaxies with humanity's ceaseless endeavor to uncover the subtle harmony that binds all things within the magnificent cosmic symphony. Traveling further into the quiet embrace of Sombrero, we become aware of the galaxy's unique influence as a gravitational anchor, an immense, stable presence subtly shaping the dynamics of smaller cosmic structures within its realm. Stellar streams, faint ribbons of stars pulled gently apart by gravitational tides, flow almost imperceptibly around it, offering astronomers delicate clues into the slow-motion dramas playing out at the edges of galaxies. These stellar streams whisper quietly of galaxies captured and gently unraveled by Sombrero's gravitational reach. By carefully mapping their subtle pathways, astronomers reconstruct histories of long-vanished satellite galaxies whose existence is now marked only by these faint stellar trails, cosmic footprints across vast distances, silent echoes of galactic mergers completed millions of years before humanity first gazed skyward. Sombrero's calm luminosity also serves as an extraordinary laboratory for astronomers studying the faint diffuse glow known as intracluster light, gentle, scattered illumination arising from stars drifting unattached between galaxies. Through meticulous imaging, astronomers detect subtle, extended halos of light around Messier 104, revealing stellar wanderers quietly journeying through intergalactic space. These lonely stars, detached from any galaxy, provide profound insights into galactic evolution, gravity's subtle interplay, and the ultimate fate of stars as galaxies age. Furthermore, Sombrero's dust lanes harbor microscopic silicate and carbonaceous grains, quietly absorbing starlight and re-radiating it at longer, infrared wavelengths. These dust particles are key actors in cosmic chemistry, gently facilitating the creation of complex molecules within the galaxy's vast expanse. Observations of this faint infrared glow subtly enrich our understanding of how chemical complexity develops in galaxies over billions of years, connecting the grand scale of galaxies with the microscopic scale of molecular interactions. Messier 104 also allows astronomers to quietly investigate the cosmic web, the intricate network of dark matter filaments connecting galaxies across the universe. The galaxy's gentle motion within this immense structure subtly alters its orientation and trajectory, providing indirect evidence of the large-scale dark matter distribution. By studying Sombrero's movements relative to this invisible web, astronomers gradually refine their maps of cosmic architecture, clarifying the unseen scaffolding upon which galaxies like Sombrero delicately rest. Sombrero's halo is additionally illuminated by faint variable stars known as RR Lyrae, stellar beacons whose gentle pulsations provide precise distance measurements. By carefully studying these periodic fluctuations, astronomers refine their understanding of Sombrero's spatial dimensions and structure. Each subtle flicker of starlight thus contributes to our cosmic mapping, enhancing the accuracy and scope of our understanding of galaxies across the universe. Moreover, advanced gravitational modeling subtly reveals how the immense mass at Sombrero's core shapes the distribution and movement of nearby stars and gas clouds. These simulations help astronomers visualize complex gravitational interactions occurring quietly beneath the galaxy's serene facade, elucidating how galaxies internally balance competing forces over cosmic timescales. As telescopes become increasingly sophisticated, astronomers also peer quietly into the faint ultraviolet glow emanating from Sombrero's younger stellar populations. Stars whose faint emissions had long remained obscured by the galaxy's dominant older population. These subtle observations offer a nuanced perspective on the galaxy's evolving nature, underscoring that even galaxies thought dormant can quietly nurture pockets of stellar rejuvenation. Even gravitational microlensing, tiny, fleeting distortions caused by the gravity of individual stars, has subtly been observed within Sombrero, briefly magnifying background stars. These delicate cosmic events allow astronomers to better estimate stellar populations and mass distributions, each fleeting cosmic blink refining our understanding of the galaxy's detailed composition. Thus, Messier 104, with its gentle yet complex characteristics, becomes a continually unfolding narrative. Every delicate observation, every quiet revelation further reveals the universe's subtle interconnectedness, one galaxy among countless billions, yet quietly guiding humanity toward a deeper, richer, and infinitely more profound understanding of the cosmos. Drawing closer still into the gentle radiance of Sombrero, we glimpse subtle evidence of cosmic weather, faint turbulence within its interstellar medium. Gas clouds drifting quietly through the galaxy experience subtle shocks and compressions, triggering localized fluctuations that astronomers delicately detect through specialized radio and infrared observations. These invisible currents quietly shape the galaxy's internal structure, influencing the delicate balance between stellar birth and dormancy. Observations also reveal faint traces of polarized starlight emerging from Sombrero, providing subtle evidence of interstellar dust grains aligned by magnetic fields. Such polarization patterns quietly signal hidden cosmic magnetism that permeates and shapes the galaxy. By measuring these faint signatures, astronomers deepen their understanding of how magnetic fields subtly guide star formation and gas dynamics within galaxies, gently yet profoundly influencing their evolution over immense spans of cosmic time. Sombrero's quiet halo of ancient stars, often overlooked due to their faintness, is also an essential testing ground for theories of stellar aging and evolution. Within this delicate halo, astronomers carefully analyze the metallicity, the abundance of elements heavier than hydrogen and helium of these old stellar populations. These subtle measurements offer crucial insights into the galaxy's chemical enrichment processes over eons, revealing how Sombrero has quietly accumulated and distributed essential cosmic materials throughout its existence. Moreover, the galaxy quietly aids cosmologists in refining models of cosmic expansion. Precise measurements of the brightness and distances to variable stars within Sombrero allow astronomers to fine-tune the cosmological distance ladder, subtle but vital steps toward understanding how quickly the universe expands. These delicate calibrations quietly anchor broader cosmological models, informing humanity's most profound questions about the universe's past and future. Sombrero also quietly influences astronomers' understanding of galaxy-scale accretion processes, the gentle accumulation of gas and dust onto its core black hole. Sensitive X-ray telescopes detect faint radiation from heated gas gently spiraling inward, subtly illuminating otherwise hidden structures. By analyzing these emissions, astronomers unravel the processes through which galaxies feed their central black holes, maintaining an intricate balance between growth and energetic outflow. Even the faintest signals from gamma-ray observatories hint at high-energy cosmic rays originating within or near Sombrero. These subtle detections suggest that within the serene galaxy, quiet yet powerful particle acceleration events occur, perhaps linked to hidden supernovae or elusive cosmic interactions deep within the galaxy's core. Each faint pulse of radiation enhances humanity's understanding of energetic cosmic phenomena quietly unfolding across the universe. Further, Sombrero serves as an observational reference for detecting elusive cosmic neutrinos, ghostly subatomic particles passing silently through galaxies. Though detection is exceedingly rare, astronomers study galaxies like Sombrero to better understand how neutrinos traverse and interact with cosmic structures, subtly contributing to our comprehension of fundamental particle physics and universal processes occurring invisibly around us. Sombrero's ancient globular clusters quietly harbor binary star systems, pairs of stars orbiting closely, subtly influencing each other's life cycles. Through delicate observations, astronomers detect interactions like mass transfer and mergers, subtly reshaping our understanding of stellar evolution and the fascinating variety of stellar relationships quietly playing out across galactic timescales. Even the galaxy's faintest outskirts reveal subtle clues about dark energy, the mysterious force accelerating cosmic expansion. By observing distant supernovae occurring behind Sombrero, astronomers measure subtle redshift variations. These measurements offer quiet, indirect insights into the enigmatic force reshaping our universe's destiny, linking Messier 104's quiet glow to profound cosmological mysteries. Thus, Messier 104 continues to whisper softly to astronomers across generations, subtly challenging assumptions, expanding horizons, and quietly guiding humanity toward a deeper recognition of our place within an endlessly fascinating cosmos. Venturing deeper into Sombrero's subtle cosmic landscape, astronomers uncover faint but revealing structures, shell-like patterns delicately surrounding the galaxy's luminous halo. These ghostly shells, gentle arcs of stars stretching quietly outward, are thought to originate from long-ago interactions with smaller galaxies, gently disrupted by Sombrero's gravitational tides. Each shell softly tells a story of galactic mergers, allowing astronomers to reconstruct past cosmic events through careful interpretation of these subtle features. In the quiet outskirts of Sombrero, astronomers also detect faint echoes of the earliest stages of galaxy formation. Streams of pristine gas, barely noticeable, untouched since the universe's infancy. By gently analyzing these primordial streams, astronomers glean valuable insights into the initial conditions that led to galaxy formation, quietly offering a window into cosmic history previously hidden in deep shadow. The faint ultraviolet light emitted by Sombrero's younger stellar regions quietly reveals subtle clues to the distribution of star-forming regions. Precise analysis shows that even this seemingly tranquil galaxy harbors quiet pockets of youthful activity, hidden nurseries softly glowing, tucked away within its vast dust lanes. These quiet revelations subtly remind us of the diverse conditions within galaxies, where dynamic stellar processes can exist quietly alongside long-established older populations. Furthermore, delicate measurements of Sombrero's rotational velocity subtly hint at variations in mass and structure across its luminous disk, suggesting intricate internal gravitational resonances, zones where the gravitational pull of stars and gas gently align in harmony. Astronomers carefully map these resonances to deepen their understanding of how galaxies maintain their delicate spiral patterns over billions of years without disrupting their elegant form. Additionally, radio astronomers have quietly detected faint molecular clouds deep within Sombrero's dust lanes, revealing traces of hydrogen cyanide and other organic compounds, subtly signaling the potential building blocks of biological chemistry. These subtle findings provide gentle yet compelling evidence that galaxies far beyond our Milky Way hold the chemical prerequisites for life, softly reinforcing the cosmic universality of chemical evolution. Sombrero's gentle luminosity also serves as a subtle guide for developing and refining techniques in gravitational wave astronomy. By studying massive stellar remnants quietly orbiting within the galaxy, astronomers can anticipate potential sources of gravitational waves, subtly preparing us to detect faint cosmic vibrations emanating from distant galaxies. Even the gentle symmetry of Messier 104 quietly influences mathematical models used to simulate galaxy evolution, providing a pristine example for testing theoretical frameworks. Astronomers carefully compare Sombrero's observed properties to computational predictions, refining our understanding of galaxy formation processes and enhancing our theoretical grasp of the universe's elegant mathematical structure. Subtle infrared observations reveal gentle thermal emission patterns from the galaxy's dust, softly illuminating how cosmic dust clouds regulate heat and energy transfer within galaxies. These faint measurements enhance astronomers' comprehension of energy cycles on a galactic scale, delicately demonstrating the quiet role dust plays in maintaining cosmic ecosystems. Moreover, the serene environment of Sombrero enables astronomers to test subtle hypotheses about star cluster survival, quietly investigating how clusters resist gravitational dispersion over long cosmic timescales. By examining the gentle dynamics within Sombrero's globular clusters, astronomers gain insight into how such star groups endure through billions of years, subtly defying gravitational erosion. Thus, Messier 104, gently positioned against the cosmic backdrop, continues quietly enriching our perspective, subtly expanding human knowledge, and softly guiding our quest to unlock deeper, more profound understandings of the universe around us. Moving ever closer to the faint edge of Sombrero's luminous realm, we find the boundaries of the galaxy not clearly drawn, but softly fading into the intergalactic dark, a transition zone where the influence of gravity delicately wanes and the galaxy slowly yields to the broader fabric of the universe. This outermost region, sometimes called the galactic fringe, holds sparse but revealing populations of ancient stars and rogue interstellar clouds. Their presence invites questions about how galaxies grow, contract, and interact with the vast, surrounding void. Within this remote periphery, astronomers identify hypervelocity stars, celestial travelers moving far faster than their stellar neighbors. These are not ordinary stars. They are thought to have been catapulted outward from the galaxy's core by gravitational interactions with the central black hole, flung into the outskirts with immense velocity. Their trajectories tell a hidden tale of the dynamic forces within Sombrero's heart and offer a rare look at the quiet but powerful processes that can accelerate stars to near-escape velocities. There is also the quiet question of cosmic dust migration. Observations reveal that some of Sombrero's dust, originating in stellar deaths, supernova remnants, and aging red giants, has managed to drift into its farthest reaches. There, this dust persists like ancient pollen on the wind, far from its point of origin. It slowly disperses into the intergalactic medium or is captured by faint, orbiting clouds, particles so small, yet bearing witness to the interior history of a galaxy now millions of years behind them. Amid this silence, astronomers also study the role of Sombrero's environment, its relative solitude compared to denser galaxy clusters. Being outside the gravitational chaos of a tightly packed galactic group, Sombrero exists in a kind of cosmic middle ground. This isolation allows researchers to separate internal evolutionary factors from external ones, offering a clearer view of how galaxies develop when left mostly to their own devices. It becomes a quiet counterpoint to the dramatic collisions seen in places like the Virgo cluster, a lesson in slow, undisturbed cosmic evolution. The question of time always lingers when contemplating Messier 104. We see it not as it is, but as it was over 30 million years ago. In that unfathomable stretch of time, entire solar systems may have formed and perished. Giant stars may have ignited, lived briefly in brilliance, and collapsed into black holes. The faint light that reaches us now is a message from a time when the Earth was vastly different, when the continents sat in other places and life on our planet had not yet taken its current form. This temporal delay is not a limitation, it is a gift. Sombrero becomes a window into deep time, allowing astronomers to witness a chapter in the galaxy's life that has long since passed. And with more powerful telescopes now peering even deeper into space and further back in time, Sombrero remains an essential reference point, anchoring our understanding of galaxies at intermediate distances, bridging the local universe with the distant past. It also serves as a reminder of the quiet resilience of cosmic structures. For billions of years, Sombrero has endured, stable, luminous, and largely undisturbed, while stars have flared and died, while galaxies nearby have merged and transformed. Its enduring presence suggests a kind of cosmic longevity that puts our human scales of time into humbling perspective. In its light, we are reminded that our entire recorded history is but a blink in the life of a single galaxy. Yet it is precisely through this light, soft, persistent, and ancient, that we are able to lift our gaze, expand our knowledge, and quietly participate in the cosmic story. For in Sombrero's silence, there is a kind of welcome. It does not demand to be understood, but invites us, gently and continually, to try. And still, Sombrero turns, silently, steadily, carving its arc through the fabric of space as it has done for eons. Though to us it appears frozen in a single frame, its vast spiral disk rotates imperceptibly, taking hundreds of millions of years to complete a single revolution. This motion, undetectable in the span of a human life, speaks to the enduring rhythms of the cosmos, ancient, slow, and profoundly patient. Encircling the galaxy's bright nucleus are tightly wound lanes of interstellar dust, each tracing an orbit shaped by gravity's subtle logic. These lanes are not static, they shift, compress, and flow, slowly rearranging themselves over time. Within these dark filaments, cold gas coalesces under its own weight, occasionally reaching the critical threshold to ignite the birth of new stars. These stars will shine for millions to billions of years, becoming new storytellers in Sombrero's ongoing cosmic chronicle. Among the stars already formed are entire families of solar systems, some perhaps solitary, others with clusters of planets orbiting gently within their host star's influence. Though far beyond the reach of current instruments, the possibility of planets in Sombrero is no longer a matter of imagination alone. With every advance in exoplanet detection techniques, the dream of mapping other worlds in distant galaxies edges closer to reality. Sombrero, serene and self-contained, may harbor entire planetary histories we have yet to glimpse. There is a serenity in its spiral, no sharp distortions, no signs of recent upheaval. It is, in many ways, a portrait of galactic maturity. The structure, while grand, has settled. This allows scientists to study how galaxies stabilize over cosmic time, how chaotic beginnings, marked by collisions, fragmentation, and violent formation, eventually give rise to order. Sombrero is the calm after the storm, the refined result of galactic adolescence long past. Its light, observed across the electromagnetic spectrum, paints a layered portrait of its internal life. In X-rays, we see the searing regions near its central black hole. In infrared, the warm glow of dust heated by star formation. In visible light, the glorious central bulge and the sharply defined dust ring. Each wavelength adds a thread to the tapestry, revealing a structure more nuanced and multidimensional than the eye alone could perceive. And behind the observable lies the mysterious, the dark matter halo, extending far beyond what we can see, cradling the galaxy in a cocoon of invisible mass. It binds the stars, governs their motion, and holds the galaxy together against the outward tug of centrifugal force. Without it, Sombrero's shape would collapse. And yet, this invisible scaffolding remains one of the great unsolved enigmas in astrophysics, a ghostly architect shaping the cosmos. There is something timeless about Sombrero, and in that timelessness, something deeply human. For as long as we've looked up at the night sky, we've sought understanding. Galaxies like Messier 104 remind us that the universe is not static, not indifferent, but alive with motion, memory, and mystery. It contains structures of astonishing grace that persist through ages beyond counting. Sombrero, distant and unreachable, becomes strangely intimate, not because we can touch it or visit it or even see it change within a lifetime, but because we recognize in it a cosmic rhythm that resonates with our own. The slow spiral of matter around a hidden center, the interplay of chaos and symmetry, the cycle of birth, transformation, and fading light. All of it, written large across the stars, quietly echoing the patterns we see in our own small world. And so we continue to watch, to measure, to imagine. Sombrero does not call out to us with drama or force. It waits in silence, allowing its story to unfold at the speed of starlight, inviting those who are willing to listen with patience, curiosity, and awe. Though distant and still, Sombrero remains a dynamic archive of cosmic evolution, a galactic library where every star, every cloud, every faint ripple in starlight is a page in a story billions of years long. It is not simply a structure in space, but a process alive in its own immense timescale, transforming even now, though the changes unfold too slowly for any one generation to witness. Within its dense central bulge, astronomers have identified not just an extraordinary concentration of stars, but a surprising diversity among them. Some are ancient, dim red giants, embers of a bygone era, while others are younger, bluer, and more luminous, suggesting waves of star formation that occurred at different moments across the eons. This complex layering of stellar populations creates a fossil record embedded in light, allowing scientists to reconstruct a timeline of activity deep within Sombrero's core. These populations move not in chaos, but in a great orchestration, some in circular orbits, others on elongated paths, weaving through gravitational harmonics governed by both visible matter and unseen forces. This motion, mapped by spectroscopic measurements, reveals subtle asymmetries and internal flows, evidence of past infall, of mergers long ago, and of a still settling equilibrium. These discoveries, delicate and precise, remind us that beneath its apparent stillness, Sombrero is constantly reshaping itself in quiet, majestic cycles. Even the dust, often thought of as mere cosmic debris, plays a fundamental role in the galaxy's story. In the thin, dark ring that encircles the luminous disk, dust grains drift through space in slow migration. They coalesce, fracture, heat, cool, and sometimes collapse into denser structures. These unassuming particles serve as cradles for stars and planets alike, and their behavior helps determine where and when new stars will be born. Observations in the sub-millimeter spectrum allow astronomers to track this cold dust, giving insight into regions otherwise invisible. And in the regions far beyond the halo where the density of matter drops toward emptiness, Sombrero continues to exert a gravitational presence. It shepherds loose stellar remnants, guides the orbits of nearby dwarf galaxies, and maintains delicate gravitational bonds with its immediate cosmic neighbors. This extended influence makes it not only a singular object, but a node in a vast web of galactic interaction, a participant in the ever-expanding structure of the universe. There is poetry in the fact that we see it as it once was, not as it is. The photons arriving at our telescopes tonight began their journey across intergalactic space 30 million years ago, before hominins walked the Earth, before the Himalayas had fully risen, before coral reefs as we know them existed. In that ancient light, Sombrero becomes a mirror of deep time. Not in a metaphorical sense, but literally. We are seeing the past preserved in the present, unchanged except by the distance it had to travel. And yet, this distance does not diminish the connection. On the contrary, it makes it more profound. That light could traverse millions of years and still reach us intact, that we have the tools and knowledge to decode it, that we can even name the structures it illuminates. This is not just a triumph of science, but of perspective. Sombrero is not out there. It is part of the same universe that shaped us. The atoms in our bodies were once fused in stars, not unlike those glowing within that distant halo. So we continue to look outward, not merely to collect data or refine models, but because there is something in us that recognizes the scale of such beauty. Something that yearns to know our place in the silent grandeur of it all. And in galaxies like Sombrero, we find that yearning reflected back. Not in words, but in light, in form, in silence. A cosmic cathedral, a spiral of time, a testament to what the universe becomes when it is left to its own devices, vast, intricate, and indescribably beautiful. As our exploration of the Sombrero Galaxy deepens, we come to appreciate not only its grand architecture but also the subtleties, the barely perceptible fluctuations in brightness, the delicate gradations of stellar color, the near-silent gravitational tensions that bind its structure. These details, though easily missed, are where the soul of the galaxy quietly resides. In its outskirts, where the stellar density begins to fade into the intergalactic dark, astronomers have detected curious asymmetries, regions where stars are not evenly distributed, where the outer halo is ever so slightly lopsided. Such irregularities suggest a past filled with quiet interactions, perhaps the remnants of long-digested dwarf galaxies or the gravitational signature of dark matter clumps drifting invisibly through its mass. These tiny imbalances offer clues to unseen processes, ghostly encounters recorded not in light, but in form. Recent spectroscopic surveys have begun to map the metallicity gradients across Sombrero's expanse, tracing how the concentration of heavier elements shifts from its luminous center to the dimmer outskirts. These gradients act as cosmic fingerprints, revealing the recycling of matter across generations of stars. In regions rich with metals, one sees the residue of countless supernovae, each explosion a moment of destruction and renewal, seeding the surrounding space with ingredients for new stars and perhaps, one day, for life. In the galaxy's infrared profile, there are signs of ring structures that don't immediately align with its visible form. These may be resonance rings formed where orbital motions of stars and gas coincide in rhythmic patterns shaped by the central bulge or even the elusive gravitational influence of a long-absorbed satellite. Like ripples frozen in time, these features show how motion and matter interplay silently, creating the elegant geometry that we perceive as balance and beauty. Even the darkness in Sombrero tells us something. The stark contrast between its glowing disk and the dense dust lane speaks to the galaxy's orientation, seen nearly edge-on from Earth. This angle provides a rare opportunity. It allows scientists to peer through the full thickness of its disk, to analyze how light filters through layers of gas and dust, to model the vertical structure of the galaxy with precision. From this vantage point, the Sombrero becomes more than a flat spiral. It becomes a cross-section of galactic life, revealing the stacking of its stellar generations, like layers of time preserved in motion. In examining the black hole at its center, astronomers note its relative dormancy. Though massive, it is not currently in a highly active state. There are no blazing quasars, no colossal jets. Instead, it waits still, quiet, heavy. But even in its calm, it dominates the galaxy's core dynamics. It subtly governs the speeds at which stars orbit nearby, shapes the distribution of surrounding gas, and may even influence the suppression of future star formation. It is a gravitational monarch cloaked in shadow. Surrounding it all is a silence not of absence, but of scale. The kind of silence where things are simply too large, too slow, too enduring to make noise in any familiar sense. Sombrero does not call attention to itself. It is not the most massive galaxy, not the most active, not the brightest. Yet it captures us precisely because of its harmony, because everything about it seems so perfectly placed, so timeless, so complete. And so the galaxy continues to drift through space, unchanged to our eyes, but in reality evolving softly, steadily. New stars will be born in its dust lanes. Others will flicker out. The halo will expand as it absorbs wandering stars. The black hole will feed, slowly and invisibly. Gravity will continue its quiet work, pulling, shaping, preserving. In this, the Sombrero Galaxy becomes more than a subject of study. It becomes a reflection of the universe itself. Not in its extremes, but in its steadiness, its layered depth, its quiet insistence on beauty. It invites us not only to observe, but to be still, to contemplate, to align ourselves, if only briefly, with the patient rhythms of the cosmos. And as we look into it from across the sea of space, we are not merely seeing a galaxy. We are witnessing an unfolding of time, of motion, of matter, of meaning. A silent spiral, etched into the night. Beneath the majestic simplicity of the Sombrero Galaxy lies a depth of order shaped not by chaos, but by persistence, an unhurried unfolding of natural laws over cosmic time. It is a structure born not of single events, but of accumulation. Of gravity's constant pull, of starlight steadily burning, of ancient gas settling into shape over billions of years. Astronomers studying Sombrero's rotation have observed something remarkable. The way its inner and outer regions move in concert, despite vast differences in distance from the galactic core. This phenomenon, flat rotation curves, is one of the clearest signs of dark matter's invisible hand. Without it, the outer stars would drift away into space, unable to maintain their high orbital speeds. Instead, they remain, locked in motion, tracing luminous arcs through the dark. It is a quiet, persistent affirmation that what we cannot see still defines what holds galaxies together. Within its disk, astronomers have identified cold molecular clouds, dense, dark, and heavy with potential. These clouds, composed mostly of hydrogen molecules, are the birthplaces of new stars. Tucked between more mature stellar regions, they lie dormant until turbulence, compression, or nearby supernovae spark gravitational collapse. This ongoing readiness to give rise to light is one of Sombrero's most understated features. Even in maturity, it carries the seeds of renewal. Between these regions of quiet birth, there are gaps, areas with little dust, little gas, a pause in the rhythm. These voids are just as telling. They suggest that star formation in Sombrero does not happen evenly, but in waves, shaped by cycles of accumulation and exhaustion. Astronomers believe feedback from older stars, stellar winds, radiation, and past supernovae can temporarily clear out regions of gas, creating these silent corridors in the stellar population. Over time, the galaxy rebalances, the gas returns, and the cycle begins again. Further afield, in the diffuse halo surrounding the disk, researchers have mapped the orbits of lone globular clusters. These tightly bound stellar families travel in graceful, elongated loops far beyond the main disk. Their paths are relics formed when the galaxy was young, perhaps influenced by gravitational encounters or shaped during mergers. The spatial distribution of these clusters allows scientists to infer the shape of the galaxy's dark matter halo, offering one of the only ways to map the invisible contours of its true mass. Even the color gradients across Sombrero speak volumes. Moving from the hot, golden core to the cooler, bluish outer rim, we witness a history of stellar evolution written in light. Older stars dominate the central bulge, swollen, cooler, glowing amber. Younger, hotter stars flicker toward the periphery where the galactic disk still hosts the conditions for creation. This gradual transition is not only aesthetic, it encodes the galaxy's chronology, its chemical maturation, and its inner balance. Occasionally, amid all this structure, a fleeting event occurs, a nova, a binary system undergoing violent change, or the sudden collapse of a massive star into a neutron star or black hole. These rare flashes in the dark are brief but critical. They enrich the surrounding medium with heavier elements. They release energy that reshapes their neighborhoods. And they serve as cosmic beacons, traveling immense distances to be captured in the lenses of human instruments millions of years later. The galaxy's quiet glow across multiple wavelengths makes it a favored target not only for professionals but for amateur astronomers around the world. Its visibility, its symmetry, and its quiet poetry in the night sky have made it an object of wonder for centuries. From dusty observatories on remote mountaintops to backyard telescopes beneath suburban skies, countless observers have paused to fix their gaze on Sombrero and in doing so become part of its story. Each photon of light that leaves Messier 104 carries not just information about where it came from, but about how far it has traveled, how the space between us has stretched, and how long it has waited. In collecting that light, in interpreting its messages, we become archivists of a universe that does not speak with sound, but with time, motion, and light. And so, even though we are separated from the Sombrero Galaxy by millions of light years and by the cold silence of intergalactic space, it continues to teach us. Not through declaration, but through presence. Through its perfect form, its balance, its quiet endurance. It is, and has been, and will be turning slowly in the void. A spiral of dust and stars. A harmony of memory and gravity. A distant, silent monument to the laws that shaped everything, including us. And still, the Sombrero Galaxy reveals itself in layers, each observation peeling back a veil, exposing deeper subtleties written not in grandeur, but in nuance. Its luminous core, so prominent in visible light, conceals a tightly knit concentration of stars, packed so densely that individual motions blur into a seamless brilliance. Yet within this brilliance, the dynamics are precise. Stars orbiting at immense speeds, their motions governed by both visible mass and the invisible pull of the central supermassive black hole. This region, often referred to as the galactic bulge, is a site of quiet equilibrium. The stars here are older, many of them enriched with heavier elements forged by previous stellar generations. Their very composition is a record of time, a chemical memory of how Sombrero gradually transformed, enriching itself through cycles of stellar birth and death, and passing on that legacy to successive generations of stars. In contrast, the stellar populations of the outer disk, less chemically evolved, offer a window into more recent epochs. These are stars formed from less processed material, born in pockets where gas and dust settled into dense clusters, ignited by the faint ripple of galactic motion or the lingering wake of ancient disturbances. The Sombrero, far from static, is a living document of cosmic processes happening at every scale and stage, microscopic and massive, ancient and ongoing. At a greater distance, scientists study the faint glow of integrated starlight beyond the galaxy's visible boundaries. This diffuse light, barely distinguishable from the blackness of space, may come from stars flung outward during early mergers or from disrupted dwarf galaxies long since absorbed. This exogalactic light is faint but rich with meaning. It speaks to the invisible histories of assembly and survival of interactions so distant in time they've left behind only these whispers in the dark. Astronomers have also begun to compare Sombrero to other galaxies of similar structure and mass, assembling large-scale surveys to search for patterns and anomalies. What they've found is that Messier 104 stands apart. It is unusually luminous for its type, with a bulge more reminiscent of an elliptical galaxy than a spiral. Its properties straddle a boundary, resisting neat classification. It is a hybrid, a transitional form, offering a glimpse into a possible evolutionary pathway, where spiral galaxies age into elliptical giants over eons of slow transformation. In that ambiguity lies its allure. Sombrero exists at a crossroads of galactic identity, not fixed to a single narrative but embodying the convergence of many. It is both disk and spheroid, both spiral and sphinx. And in this complexity, it becomes a keystone for astronomers working to understand how form follows history in the life of galaxies. Even Sombrero's gravitational influence extends beyond what we can see. It shapes the trajectories of passing gas clouds, subtly tugging at loose intergalactic material. Some of this material may someday be drawn and captured and assimilated into the galaxy's outskirts, contributing new building blocks to its future evolution. Others may skim past, altered slightly in course, adding their mass to the ongoing ballet of local gravitational dynamics. The very space around Sombrero is a stage for potential, an environment that might one day look different. In cosmological time, galaxies continue to change even in apparent stillness. Over the next few billion years, Sombrero may encounter new companions or slowly accrete matter from its surroundings. It may see its star formation dwindle, its spiral arms fade, and its light shift toward the infrared as its youngest stars age and die. These slow, inevitable changes are already beginning, quietly, without fanfare. And through all of it, we remain observers. Not outside the story, but deeply within it, because our understanding of galaxies like Sombrero helps define who we are. It reminds us that we are shaped by the same physics, born of the same particles, destined to the same ends. In every direction we look, we find echoes of ourselves written in the stars. The Sombrero Galaxy does not shout its significance. It speaks in the language of balance, light, and time. It waits, serene and radiant, at the edge of perception, offering all who look upon it a single, enduring message. The universe is not merely vast. It is connected, structured, profound, and, in its quietest places, overwhelmingly beautiful. Even now, with ever more sophisticated instruments trained upon it, the Sombrero Galaxy holds mysteries it has not yet surrendered. Its elegance is not only in its visible form, but in what remains elusive data encoded in wavelengths we've only recently begun to explore, processes unfolding on timescales that exceed our entire species' memory. In high-energy regimes such as the gamma-ray and hard X-ray bands, Sombrero reveals an unexpected quiet. Unlike galaxies with violently active cores, it shows no dramatic flares or blazing jets. But this silence is informative. It tells us that the supermassive black hole at its center, though vast and gravitationally dominant, is presently dormant, quietly influencing the galaxy not through cataclysm, but through subtle gravitational shaping. This phase of stillness may last for millions of years, or it may be a pause between outbursts. In the life of a galaxy, such periods are part of a natural rhythm, the inhalation between cosmic events. Meanwhile, gravitational influences ripple outward. The galaxy's rotation, bulge-to-disk ratio, and stellar velocity dispersions are all elements that computational astrophysicists fold into galaxy evolution models. Sombrero, due to its atypical combination of features, helps challenge and refine those models. It doesn't fit cleanly into conventional categories. This makes it not an exception to be ignored, but a key to expanding the frameworks we use to understand galactic structure and transformation across cosmic time. More intriguing still is the possibility of intermediate-mass black holes lurking within Sombrero's globular clusters. These hypothetical objects, smaller than the central supermassive black hole but larger than stellar mass remnants, are among the most elusive entities in astrophysics. Some globular clusters in the halo exhibit velocity patterns that hint at something more than stellar gravity at their core. If such black holes exist, they may represent missing evolutionary links in the formation of the behemoths we see in galactic centers. Sombrero could be one of the quiet testing grounds where this mystery finally resolves. Even beyond the science, there's the philosophical gravity of the galaxy. Its near-perfect symmetry, the clarity of its silhouette against the black, has made it one of the most iconic deep-sky objects ever photographed. But what draws us is more than just shape or scale. It's what the image represents. A structure of such immensity, hanging in the dark, formed from the same matter as ourselves, following the same rules of motion and energy. It is a mirror held up to the deep nature of reality. This name, Sombrero, grounds it in the familiar, a human comparison, a shape drawn from our world, imposed upon a galaxy so distant its light predates our civilization many times over. And yet, that naming is not an act of diminishment, but of connection. It is how we claim kinship with the cosmos, not to own it, but to understand it, to make it part of our story. In our digital age, when telescopes operate from mountaintops and orbiting satellites, when observatories collect petabytes of data, the Sombrero Galaxy remains a gentle constant. It doesn't explode or flicker. It doesn't roar. It turns and shines and waits, not just for astronomers, but for poets, philosophers, artists, and all who seek perspective beyond the immediate. It reminds us that stability can be as awe-inspiring as change, that beauty is not always in motion, but sometimes in endurance. And long after our brief epoch has passed, after our cities have faded and our names have turned to dust, Sombrero will continue. Unfolding, evolving, balancing mass and light in an endless exchange. Stars will still orbit its center. Dust will still drift in its dark lanes. Photons will still depart its outer rim, crossing the cold vacuum toward unknown eyes in another time, on another world, circling another sun. It is, in the end, not only a galaxy. It is a meditation in space, a monument to time, a quiet, ongoing answer to the question of what the universe becomes when it is left to be exactly what it is. In the vast silence that stretches between galaxies, where light travels alone for millions of years, the Sombrero Galaxy continues its ancient path, unobserved but ever luminous. Its light, though faint by the time it reaches us, is layered with complexity. Each photon carrying a history, each wavelength a cipher for the forces that shaped it. One of the more delicate revelations of modern astronomy comes from studying the thermodynamic properties of galaxies like Sombrero. Using far-infrared and sub-millimeter observations, scientists detect the faint warmth of cold dust material hovering just above absolute zero, invisible to the eye yet essential to the galaxy's ecosystem. This dust, composed of silicates, carbon compounds, and ices, is a remnant of stellar evolution. It absorbs and re-radiates energy, regulating the cooling of interstellar gas and quietly influencing when and where stars can form. Such dust is more than debris, it is cosmic memory. The composition and distribution of this material tells the story of long-dead stars, their internal furnaces having produced the elements that now drift through the galaxy's spiral lanes. In every flake of dust, there is the aftermath of creation, the ashes of old stars awaiting transformation into the next generation of suns, planets, and perhaps, one day, consciousness. Further insights come from the study of planetary nebulae, dying stars in their final luminous breath, scattered like tiny lanterns across Sombrero's disk and halo. These ephemeral structures offer precise measurements of the chemical makeup and motions of stars, especially in regions too distant or diffuse for traditional spectroscopy. They are temporary but luminous. Their fleeting nature allows astronomers to take snapshots of the galaxy's stellar population in transition, catching it mid-thought in the long meditation of galactic evolution. Even silence, when mapped across the galaxy, reveals something. In radio frequencies, astronomers have detected regions of surprisingly low hydrogen density voids in the galactic disk that hint at past disruptions. Perhaps long-forgotten interactions with invisible dark subhalos, or the fading imprint of an ancient galactic wind that once swept through, clearing a path through the interstellar medium. These absences speak just as clearly as emissions. They remind us that the past of any galaxy includes moments of removal as much as of creation. Moreover, the gravitational influence of Sombrero continues to extend beyond its visible stars. Ultra-diffuse galaxies, ghostly companions barely clinging to their structure, may orbit silently within its dark matter halo. These faint, almost transparent galaxies provide clues about the limits of star formation, about how little visible matter is required to define a galaxy, and about how gravity alone can hold together systems nearly invisible to conventional telescopes. Sombrero becomes, in this way, a shepherd of unseen worlds. With time-lapse astronomy, long-term observations over decades, tiny changes in brightness have been cataloged within the galaxy. Some are due to variable stars, others to background supernovae briefly outshining entire star clusters. These minute fluctuations, carefully monitored, transform Sombrero from a static object into a dynamic stage. We are beginning to witness it not only as it was millions of years ago, but as something slowly shifting before our eyes. And yet, for all the sophistication of our tools and the precision of our measurements, the emotional power of the Sombrero Galaxy remains unchanged. There is something about its form, its symmetry, its clarity, the stark contrast of light and shadow that makes it not just a scientific object, but a symbol. A visual koan from the cosmos. A reminder that order and beauty can emerge not from intention, but from the unyielding laws of nature, patiently working across unimaginable spans of time. Every person who has ever pointed a telescope toward it has, in a way, participated in that quiet legacy. From the first hazy sketches drawn in the 18th century to the digital imagery beamed back from space telescopes today, we have continually reached out toward it. And in that reaching, we find more than data, we find meaning. For Sombrero is not merely a galaxy seen through instruments. It is an idea made visible, that structure can emerge from emptiness, that harmony can arise without a conductor, that the universe, even in its quietest places, is always creating something worthy of wonder. And though it lies far beyond our grasp, its light arrives just the same, softly, steadily, offering itself to any who choose to look. Beyond the beauty, beyond the symmetry, beyond even the science, the Sombrero Galaxy carries within it a quiet, enduring truth that the cosmos is not static, but forever becoming. Even now, as it spins in silence against the backdrop of deep space, Sombrero is slowly changing, its spiral arms unwinding, its stars aging, its dust migrating. Nothing within it is still. And yet, this transformation is so gradual, so imperceptible to our senses, that it gives the illusion of permanence. This illusion is powerful. When we look at Messier 104, we are tempted to see it as fixed, eternal, whole. But every part of the galaxy is in flux. The stars in its vast disk are locked in differential rotation. Those nearer the core complete orbits in far less time than their distant counterparts. Over billions of years, this creates a gentle winding and stretching of its spiral structure, a slow-motion reconfiguration that defies the idea of constancy. This great halo, often overlooked, is equally vital. Composed of ancient, metal-poor stars, some perhaps nearly as old as the universe itself, the halo encases the galaxy in a sphere of deep time. These stars do not follow the neat, circular paths of disk stars. They move in elongated, eccentric orbits, plunging through the galaxy's core and arcing far into space. Their patterns are erratic, but meaningful, fossil evidence of a chaotic youth, when smaller protogalaxies collided and merged to form what would become Sombrero. Indeed, mergers have shaped this galaxy more than its serene face would suggest. While it lacks the tidal tails and warped arms typical of recent interactions, subtle signatures remain. Star clusters on unusual trajectories, gaps in the stellar population, streams of stars moving independently of the disk. These are the ghosts of long-absorbed companions, their identities dissolved into the larger structure, but their footprints lingering in motion and light. And though the galaxy currently appears quiet, devoid of the intense starburst activity seen in some spirals, it is not without drama. Deep within its core, slow accretion onto the central black hole continues. Matter, drawn inward over millennia, heats to extreme temperatures, emitting X-rays as it spirals into darkness. The black hole is not actively feeding in great quantities today, but it remains ready, its hunger eternal, its presence shaping the galaxy's very core. On a different scale, the magnetic fields threading through Sombrero's interstellar medium continue to influence how matter organizes. Though invisible to the naked eye, these fields guide the movement of ionized gas, influence the collapse of dust clouds, and even affect the orientation of new stars. Observing them requires sensitive instruments, yet their role is fundamental. A silent architecture laid across the galaxy's structure, keeping its internal flows in balance. We are only just beginning to understand these fields, just as we are only beginning to grasp the deeper unity that connects the galaxy's many parts. Stellar orbits, gas densities, magnetic lines, gravitational waves, chemical signatures, each speaks in a different register, but all belong to a single, coherent song. Sombrero is not just an object. It is a system, a synthesis, a slow harmony unfolding across cosmic time. And in studying it, we are not only reaching outward, we are reaching backward, forward, and inward as well. Backward into the origins of structure, forward into the destinies of galaxies, inward toward our own capacity for wonder and reflection. Because, ultimately, this galaxy, like all others, is not separate from us. The same physics that governs the motion of its stars governs the blood in our veins. The same elements that shine in its heart were forged in the same kinds of stars that seeded our own solar system. The same dark matter that surrounds it flows unseen around us too. To gaze upon the Sombrero Galaxy is to remember that we are not spectators of the universe, we are part of it. Made of its dust, moved by its gravity, lit by the same ancient fires. And though the galaxy may lie 30 million light-years away, its presence in our sky collapses that distance. For a brief moment, when we observe it, its story becomes part of our own. Not as something alien and unreachable, but as something familiar, shared, and quietly eternal. As we continue to explore the Sombrero Galaxy through every available lens, we begin to appreciate its role not merely as a single object, but as a node in the vast, interconnected network of cosmic evolution. It is one piece in a great mosaic, a structure shaped by the same forces that have sculpted the universe from its earliest moments, bearing the marks of both ancient turbulence and enduring order. In its current state, Sombrero may seem solitary, adrift in a quiet patch of the cosmos. But this isolation is relative. The galaxy is part of the Virgo 2 cloud, a sprawling filament of galaxies loosely associated with the greater Virgo cluster. Invisible bridges of dark matter likely connect Sombrero to its neighbors, binding it within an enormous gravitational scaffold. These connections, too vast and faint to see directly, are revealed through simulations and gravitational lensing studies which trace how light from distant galaxies bends subtly around unseen mass. These dark matter filaments are not decorative, they are structural. They guide the migration of galaxies, the flow of cold gas, and the clustering of matter on the largest scales. Sombrero follows these silent contours orbiting within a larger gravitational geography. Though we perceive it as an individual entity, its evolution is entwined with the unseen infrastructure of the cosmos itself. Zooming inward again, astronomers have studied the temperature of Sombrero's gas at multiple scales. Some regions show signs of shock heating, evidence that interstellar material has been compressed, possibly by waves of star formation or faint outflows from the core. In contrast, other regions are cooling, slowly losing energy and collapsing under gravity's subtle pull. This delicate thermodynamic balance between heating and cooling, pressure and collapse is what determines whether stars are born or left waiting. And the stars that do emerge are not all the same. Sombrero hosts a wide variety of stellar populations, short-lived blue giants that burn fast and vanish in supernovae, long-lived red dwarfs that may persist for trillions of years, rare variable stars that pulse rhythmically, revealing their mass and luminosity through their flickering light. These stars are not just lights in the void, they are clocks, thermometers, and chemical factories, each providing data about the galaxy's inner life. Some of these stars have been observed to host exoplanets, though direct detection is still beyond our current capabilities at this distance. Their light curves and chemical signatures hint at the presence of planetary systems. The idea that there could be planets orbiting stars within Sombrero, rocky worlds bathed in alien starlight, perhaps with atmospheres, weather, and even primitive chemistry, transforms the galaxy from a beautiful abstraction into something more intimate. It becomes a garden of possibility. As instruments become more sensitive, astronomers have also begun to search for ultra-faint satellite galaxies near Sombrero. These tiny companions, held loosely in the galaxy's gravitational grip, are barely distinguishable from the background. Yet they matter deeply. Their presence or absence can confirm or challenge our models of dark matter distribution and galactic assembly. Sombrero's satellites, like tiny moons around a great planet, carry vital information about how structure forms on the smallest galactic scales. There are also efforts to simulate Sombrero in virtual space, feeding its properties into cosmological models, allowing it to evolve under the laws of physics in powerful supercomputers. These simulations are not just visualizations. They are experiments. Scientists tweak initial conditions, adjust dark matter parameters, and observe how closely the resulting virtual galaxy matches the real one. Through this process, Sombrero becomes both subject and tool, a touchstone by which we measure the accuracy of our understanding. And throughout all of this, its quiet light continues to arrive on Earth. Year after year, the same ancient glow travels the dark, reaching us with unwavering consistency. It strikes the sensors of space telescopes, bounces off the mirrors of ground-based observatories, and lands softly on the retinas of amateur astronomers who still, after all this time, point their instruments skyward with the same awe that first inspired the search. In the Sombrero Galaxy, we see not only what the universe is but what it allows. Stability and transformation, isolation and connection, silence and unfolding complexity. It reminds us that the cosmos is not an empty stage, but a living structure, breathing, turning, cycling through time. And in that spiral, 30 million light-years from Earth, we find a reflection of our own long journey through space and time, still unfolding, still becoming, under the same ancient stars. Even as we chart every observable feature of the Sombrero Galaxy, its structure, its dynamics, its stellar populations, we remain aware that there is a dimension to it we may never fully grasp, the experiential. For what does it mean for something so vast, so ancient, and so orderly to exist, largely untouched, in the cold depths of space for billions of years? What does it mean that such a structure can be, and has been, entirely indifferent to our presence, yet so strangely resonant with our sense of beauty, proportion, and harmony? Perhaps part of that resonance lies in its proportions. The ratio between its bright central bulge and its flat, darkened disk creates a visual balance that feels almost deliberate. This is not symmetry in the strict mathematical sense, but an organic equilibrium: light and shadow, mass and space, form and emptiness. The thick, golden sphere of old stars seems to float atop the razor-thin lane of dust like a jewel in a velvet setting. It's no wonder that it evokes images of familiar things. A hat, a halo, a ringed world, metaphors that draw the distant closer to our minds. But for all its serenity, there is also tension. The Sombrero Galaxy is held together by a careful contest of forces. The outward centrifugal push of orbiting stars and gas, the inward pull of gravity, the resisting pressure of interstellar gas, the frictionless influence of dark matter. Everything that exists within it, every orbit, every molecular cloud, every flickering star, does so because of a finely tuned balance that could, in theory, be disrupted. But it is not. It holds. It endures. This endurance is not passive. It is dynamic. Over immense timescales, Sombrero is constantly rebalancing itself. Stars are migrating through the galactic disk, sometimes pulled into the bulge, sometimes flung outward. Supernovae stir the gas, injecting momentum and heat. The halo's diffuse matter moves along elliptical orbits, warping ever so slightly under the influence of passing mass. It is a system always in motion, never repeating, always recomposing itself within the framework of fundamental laws. And even the stars that no longer shine leave behind remnants: white dwarfs cooling slowly into black cinders, neutron stars spinning silently in the dark, and black holes wandering the halo invisibly. These stellar remnants are part of the galactic memory, silent records of the galaxy's formative epochs. Their mass still exerts influence. Their trajectories still trace invisible lines through the galaxy's space. They remain even as their light has faded. In the outermost limits of Sombrero, far beyond the disk and halo, the gravitational reach of the galaxy slowly diminishes. Here, between Sombrero and intergalactic space, lies a boundary that is neither fixed nor sharp. The motions of stray stars and faint dwarf galaxies are subtly shaped by this invisible edge, a permeable frontier where Sombrero's influence fades into the larger cosmic web. These transition zones are critical to understanding the role galaxies play in structuring the universe, not as isolated islands, but as knots in a cosmic tapestry that stretches far beyond what we can see. And as we peer deeper into these edges, using instruments that collect the faintest possible light, we sometimes find surprises: ultra-faint star streams, subtle arcs of disrupted matter, or anomalous clumps that defy explanation. These findings are the breadcrumbs of past events: minor mergers, tidal disruptions, ancient accretions. They are the shadows of history written across space. Sombrero, in this way, is not a single thing. It is the culmination of everything that has happened to it. It is the aggregate of every collapse, every burst of radiation, every orbit, every flicker. It is what remains after billions of years of motion, attraction, interaction, and silence. And perhaps that's the deepest reason it draws us in, not simply because of its form or brightness, but because it represents permanence built from impermanence. It is not static, yet it persists. It is not frozen, but in continuous motion. And in that motion lies a lesson that the universe, even at its grandest, is shaped by innumerable small, quiet changes adding up over time to something enduring, magnificent, and whole. The Sombrero Galaxy continues its turn, unaware of our attention, yet now forever marked by our gaze. We have seen it. We have measured it. We have wondered at it. And that act of attention, though infinitesimal compared to the scale of the cosmos, becomes a part of the story too. A moment of connection between what is far away and what is within. In the grand silence of the cosmos, the Sombrero Galaxy offers something rare, a sense of continuity that stretches far beyond the fleeting scale of human time. It is not merely ancient, it is enduring. And this endurance, this ability to maintain coherence amid the vast entropy of space, is itself an act of quiet defiance. A spiral of stars holding shape while the universe around it expands and darkens. But endurance does not mean stagnation. Even the oldest stars in Sombrero's thick bulge, once thought to be simple relics, show signs of subtle dynamism. Their compositions reveal traces of elements that shouldn't be there, rare isotopes that hint at interactions, mergers, or stellar mixing events previously unseen. The stars tell us they have histories too. That even in the most stable corners of the galaxy, nothing is untouched by time. Between the stars, there are spaces filled not with silence, but with possibility. The interstellar medium, the gas and dust that flows through the galaxy like an invisible tide, acts as both a memory and a promise. It carries within it the ashes of dead stars and the potential for new ones. It is where chemical complexity builds, where carbon chains form, where organic molecules quietly accumulate. Sombrero, in its way, is a galactic crucible, still nurturing the raw ingredients of life, even in its middle age. There is also the unseen architecture that gives the galaxy its shape, the gravitational scaffolding of dark matter. Though it emits no light, we know it is there surrounding Sombrero like a cloak. The galaxy's rotation speeds, its extended halo, and the orbits of its satellite systems all point to a hidden presence. Without this invisible framework, the galaxy would unravel. With it, it remains whole. Dark matter does not clump or collide the way visible matter does. It simply gathers quietly into vast, diffuse halos, creating the gravity wells in which galaxies can form and evolve. Sombrero rests in one such well, a ripple in the early universe amplified by time, now shaped into starlight. And that halo is still growing, still drawing in matter from the filaments of the cosmic web, still deepening. On occasion, a rogue object, a gas cloud, a star, or a dwarf galaxy will wander too close, drawn into the orbit of Sombrero. These events are almost invisible in human time, but over millions of years, they can reshape the edges of the galaxy. A faint ripple in the halo, a new stream of stars, a slight perturbation in orbital patterns. These subtle signs are how we know the galaxy is not alone, not isolated, but part of a wider, breathing cosmos in constant motion. And then there is light, Sombrero's constant gift to us. From its core, from its arms, from its halo, it emits photons that journey for millions of years across the void. By the time they reach Earth, they are ancient messages. Not just signals from another part of space, but from another part of time. We don't see Sombrero as it is, we see it as it was when our ancestors still roamed in small tribes and the world was raw and wild. This time-traveling light connects us to a deeper story, one that stretches far beyond our species. It reminds us that the universe is not something that simply surrounds us. It precedes us, includes us, and will continue without us. But while we are here, we get to witness it. We get to look up and to understand, if only partially, what we are part of. In every era, civilizations have looked to the sky to place themselves in context. For us, galaxies like Sombrero offer not only wonder, but clarity. A luminous spiral held together by invisible threads, gently spinning in the void, this is what the universe is capable of when left to its own laws. And in studying it, we glimpse not only the cosmos, but the potential for insight, for reverence, for humility. Sombrero continues, unchanged by our observations, yet enriched by our understanding. Each new image, each new spectrum adds detail to a portrait still unfinished. And though we may never touch it, or send probes to its stars, or walk its distant worlds, our knowledge reaches it. Our light, however faint, travels back. Two galaxies, separated by space and time, joined for a moment by attention, by meaning, by light. Sombrero's elegance is immediate. Its luminous central bulge and dark, sweeping dust lanes strike the eye with a balance of simplicity and depth. But beneath that initial visual impression lies an ever-expanding complexity, one that emerges more fully the longer we look, the deeper we listen to its light. At high resolution, that smooth bulge begins to resolve into countless stellar points, dense fields of stars layered across one another like sediment. Some shine in the infrared, others in ultraviolet. Some rotate in alignment with the galactic plane, while others drift at oblique angles, hinting at ancient infalls, captured populations, and migrations over billions of years. It is not a monolith, but a mosaic, a layered monument of stellar histories, each one a chapter in the galaxy's evolution. Closer to the plane of the disk, astronomers have cataloged subtle asymmetries in the gas distribution, patterns that suggest lingering echoes of past tidal encounters or internal instabilities. These anomalies are faint, almost ghost-like, but their presence is revealing. Even galaxies that seem symmetrical at first glance carry within them the scars and signatures of a more chaotic past. Sombrero, though serene in silhouette, holds such signatures in abundance. There is an art to seeing these features, not in the traditional sense, but in the patient decoding of data. Algorithms sift through the galaxy's light, separating signal from noise, mapping temperature, metallicity, density, and motion. What emerges is a multidimensional map of an entire stellar metropolis, stars moving along invisible roads, clouds drifting on thermal currents, gravitational wells anchoring entire stellar neighborhoods. And as our instruments sharpen, we begin to trace the whisper of Sombrero's past in its most delicate details. For instance, its unusually bright halo, the result of a dense concentration of ancient stars, may be the product of a merger early in its life, an event that deposited a vast swarm of stars into the outskirts while leaving the disk relatively undisturbed. If true, it would suggest that Sombrero was not always as we see it now, but once bore the raw and turbulent marks of galactic youth, only later refined by time. Beyond the visual and the structural, there's the acoustic, a metaphorical dimension, but one that matters. Scientists can now sonify data from galaxies like Sombrero, converting spectrographic readings into sound. Though it's not how the galaxy sounds in space, which is silent, it's how its energy might resonate if we could hear light. These soundscapes, composed of frequency and flux, offer an eerie reminder that even in silence, the cosmos pulses with rhythm and movement. From its black hole to its outermost hydrogen fringe, Sombrero is more than a luminous spiral. It is a record of equilibrium, not a static balance, but a living one. It adapts. It absorbs new material. It digests. It reorganizes. Its shape is the outcome of countless competing forces: collapse and expansion, friction and flow, entropy and gravity. That such a system can remain coherent across such enormous scales of time and space is a quiet miracle. But perhaps one of its most mysterious elements is what we still don't know. There may be stars hiding behind its densest dust lanes, unseen and uncounted. There may be entire satellite galaxies faint enough to evade detection even by the best instruments we have. There may be rogue planets wandering its halo, unbound to any star. There may be molecular compounds forming in cold gas clouds that hint, in their chemical shadows, at prebiotic complexity. It is these possibilities that keep Sombrero alive in the minds of scientists and storytellers alike. It is not just a collection of data points, it is a vessel of potential, a wellspring of unanswered questions. Every photon it sends to us, every tiny shift in its spectral lines, is a gentle nudge forward, a sign that the galaxy still has more to tell if only we learn how to ask. And through all of this, Sombrero turns. Quietly. Invisibly. A slow revolution measured not in hours or days or even centuries, but in the rise and fall of civilizations. While entire species come and go on planets scattered throughout the universe, this galaxy continues its stately arc. Not waiting for us, not shaped by our gaze, but offering its presence all the same, a beacon of order, complexity, and time. The Sombrero Galaxy continues to orbit in that vast, invisible current of the universe, not as an isolated artifact but as an evolving participant in a grand, interconnected system. Even now, as we refine our models and push the limits of observation, there are aspects of Sombrero that remain just beyond our reach, not because they are hidden maliciously, but because they are subtle, cumulative, and require time, patience, and humility to understand. One such frontier lies in the study of cosmic rays, high-energy particles that travel at near-light speed, occasionally originating from galaxies like Sombrero. These particles, though incredibly sparse, can offer glimpses into the energetic processes at work within the galaxy. A supernova in one of Sombrero's arms, invisible to our eyes today, may have launched a spray of particles that even now races silently across intergalactic space. Tracing their origin, though difficult, ties us into the larger energetic dialogue happening across galaxies, one we are only beginning to interpret. Sombrero may also harbor regions of low-frequency radio emission produced by interactions between electrons and magnetic fields. These emissions don't dazzle like the bright bulge or the crisp dust lane, they are whispers rather than signals, requiring sensitive radio observatories to detect. But within those faint emissions lies a story of aged star populations, of long-cooled remnants, and of the ghostly infrastructure of galactic magnetism that underpins the movement of particles and energy throughout the system. In the past, galaxies were viewed almost as finished sculptures, static portraits of cosmic artistry. But the deeper we study systems like Sombrero, the more we understand them as processes. Not fixed forms, but living mechanisms. The stars are not just ornaments, they are agents of change. Their radiation sculpts gas clouds. Their deaths enrich the medium. Their motion stirs the disk. Galaxies are not monuments, they are ecosystems. Sombrero's disk, while sharp and defined, is likely composed of multiple structural components: a thin disk where most of the younger stars reside, a thicker, puffier disk of older stars, and perhaps even a hidden stellar bar at its center, channeling gas inward over time. If such a bar exists, it would be another sign of inner dynamism, matter slowly funneling toward the core, feeding the black hole, triggering bursts of star formation in episodic waves. What appears still is, in truth, quietly rotating with layered complexity. Its environment also deserves attention, not just the halo of globular clusters or the potential dark satellites, but the cosmic voids and faint filaments that surround it. There may be streams of warm gas flowing towards Sombrero from the intergalactic medium, so diffuse they are almost impossible to detect directly. These filaments could be feeding the galaxy, providing a slow but steady infusion of raw material. They could explain why certain regions show unexpected star-forming activity, why certain spiral features persist. And then there's time, perhaps the most fundamental element. If we could watch Sombrero over 1 billion years, we would see its arms stretch and fade, its halo swell with captured material, its disk thicken as stars age and migrate. We would witness the slow decline of star formation, the gradual dimming of hot, young stars, the cooling of interstellar gas. We might even see new structures emerge, rings, warps, satellite streams brought on by interactions that have not yet begun. And still, there would be beauty. Not the kind that depends on human symmetry or contrast, but the beauty of persistence. Of order maintained through quiet tension. Of structure arising from invisible rules. Of a galaxy shaped entirely by gravity, time, and the raw materials of the universe, and yet producing something that inspires awe, reverence, and curiosity. Sombrero does not ask to be understood. It simply continues. And in doing so, it offers us a place to direct our deepest questions. What does it mean for something to last? How does structure emerge from chaos? What is our role in observing, in interpreting, in preserving meaning across time? As we look deeper into Sombrero, into ourselves, we discover that these are not separate inquiries. They are one and the same. For in every observation we make, in every photon we record, we add to the human archive of wonder. And long after our instruments fall silent, the galaxy will still shine, still spiral, still scatter its light across the dark. Sombrero's legacy, like that of all galaxies, is not written in grand gestures but in countless quiet interactions layered over deep time. At any given moment, millions of stellar processes unfold within its vast disk and halo, each unremarkable in isolation, yet together forming a symphony of motion, transformation, and continuity. Among the most delicate of these processes is the slow migration of stars. Over hundreds of millions of years, stars do not stay fixed in their birthplaces. They drift, nudged by gravitational resonances, spiral density waves, and subtle perturbations in the galactic disk. In Sombrero, this radial migration creates a subtle blending of populations, moving older stars outward, mixing younger stars inward, erasing clear boundaries and painting the galaxy with a seamless gradient of age and metallicity. This gradual reorganization tells us that even in seemingly rigid structures, fluidity prevails. Spiral arms are not permanent fixtures but transient patterns. Waves of density through which stars and gas pass like schools of fish through ocean currents. As they pass through, gas compresses, stars ignite, and then move on, leaving the illusion of a stable form. Sombrero's arms, too, are living patterns, not static architecture. Further afield, the dark matter halo remains the least understood component, and yet it defines almost everything about Sombrero's form and fate. New simulations suggest that this halo is not a uniform sphere, but clumpy, anisotropic, and dynamic. Within it, smaller dark subhalos orbit invisibly, ghosts of failed galaxies or remnants of ancient mergers. Though they contain little or no visible matter, their gravity subtly tugs at stars and gas in the outer disk, creating warps, flares, and faint trails that can only be explained by these hidden companions. And in the intergalactic space beyond, Sombrero interacts with the cosmic microwave background, the afterglow of the Big Bang. Though it seems unrelated, the galaxy's motion through this primordial radiation bath leaves an imprint, a slight dipole signature detectable in precision cosmology. In this way, Sombrero is not only shaped by the local conditions of its matter and mass, but also by the very structure of space-time itself, its velocity, its orientation, even its gravitational influence stitched into the larger geometry of the universe. Within Sombrero, stellar deaths continue to sow the seeds for future generations. When massive stars explode as supernovae, they forge heavy elements, iron, calcium, gold, and hurl them into the surrounding medium. These elements enrich the galaxy's gas supply, ensuring that the next generation of stars and planets is more chemically diverse. Some of this material may eventually coalesce into planets, moons, and possibly the building blocks of biology. In this way, Sombrero does more than shine, it prepares. It creates the conditions under which complexity can arise. Every sun-like star it forms, every planetary system that emerges is a small experiment in structure, a local laboratory for chemistry, dynamics, and potentially the emergence of life. We may never know if life exists in Sombrero. The distances are too great, the stars too numerous, the signals too faint. But the physical processes are universal. The carbon in our cells, the calcium in our bones, the iron in our blood, all forged in galaxies like this one. Galaxies that quietly conduct the alchemy of matter, shaping simple hydrogen into complexity through the relentless logic of stellar evolution. Sombrero, then, is not just a distant system, it is a template. A record of what galaxies can become when left to evolve in peace. It shows us how order emerges from gravitational chaos, how light can persist through time, and how matter organizes itself into forms that, one day, may look back at the stars. And perhaps this is the most powerful insight, that observation itself, consciousness, curiosity, awareness, is not separate from the cosmos but part of its unfolding. Our ability to look across millions of light years and make sense of what we see is a continuation of the same processes that formed the stars and stirred the dust. In the Sombrero Galaxy, we find not just a place, but a moment. A moment where structure has aligned, where light has lasted, and where, by some cosmic grace, we have noticed. There is something quietly transcendent in realizing that the Sombrero Galaxy, though unimaginably far, becomes part of our world the moment its light touches us. That light, traveling across 30 million years of emptiness, carries with it no sound, no message, no intention. And yet, when it arrives, it transforms. It becomes data. It becomes beauty. It becomes meaning. We catalog its stars, model its motion, and map its spectral lines, but beyond all this empirical richness, there remains something that cannot be quantified, the sensation of scale. The awareness that this entire spiral of stars, dust, gas, and dark matter is only one among hundreds of billions. That its billion suns are mirrored in a sky where nearly every point of light is its own immense system. Sombrero is not remarkable because it is unique, it is remarkable because it is typical. And yet it leaves us breathless. Even its name, Sombrero, draws from human language, from metaphor, from a need to bring the unfamiliar into the realm of the known. And perhaps this is what we do best, we find stories in the stars. We read the shapes of galaxies like myths carved in light. We project our wonder outward, and the cosmos, silent, vast, and indifferent, gives us back the material for awe. And so, Sombrero continues. A vast island of stars turning gently in space. A system governed by gravity and enriched by time. A structure as indifferent as it is beautiful. We may never visit it. We may never know its worlds, its dust storms, or its long-lost collisions. But in studying it, in naming it, in contemplating it, we affirm something vital, that the universe can be known. That light carries stories. That silence is not absence, but depth. As we look toward this elegant spiral etched into the void, we are reminded of the paradox at the heart of cosmology, that the farther we gaze outward, the more deeply we look within.